All right, hi everybody. We're going to go ahead and do our review for chapter 5 for all of our triangles. So I'm going to run through some of these examples just to make sure everybody's on the same page and knows what's going on. I'm going to save a lot of the calculating for you, so please pause the video as you need to do the calculation to kind of think things through, and then make sure that you can get the right answers. Remember, half the battle for these is making sure you type them in correctly. So we're going to start with right triangles. So drawing those pictures really helpful. So we start on the inside and work our way out. So if they're telling us the inverse tangent is 2/3, I'm going to go ahead and draw a picture of that. So that means that the tangent is 2/3. And remember, tangent is opposite over adjacent. So the opposite side would be 2, saying that's my angle. And the adjacent side would be 3. So the first thing I'm going to do is figure out what that third side would be, my hypotenuse. So I'll just call that r there. So we're going to do the Pythagorean theorem. So r squared equals 2 squared plus 3 squared. That means my radius looks like it'd be the square root of 13. Okay, so that would be this side. So what ratio then would sine be of that same angle? So sine is opposite over hypotenuse. So the sine of that angle, I guess I'll just call it theta, so we have something to put in there. So the sine of that angle theta would be the side opposite, which is 2 over the hypotenuse, which would be square root of 13. And remember, we need to rationalize, so that would be 2 square root of 13 over 13. So part of what you're going to have to do on the test is make sure that you can solve for things in right triangles. So let's try a couple more right triangles real quick. All right, so they're telling us that side F, so let's go ahead and label. Across from F is 9 and side D is 13, which means we don't know little b. And we want to find the measure of angle B. All right, so take a look at angle B and see what you know. You know the side that's adjacent, which is 9, and the hypotenuse. So think about which function is adjacent over hypotenuse, and that would be cosine. So cosine of angle B would be 9 over 13. So then on your calculator, you're doing the inverse, oops, I'm writing sine, inverse cosine of 9/13. Make sure you're in degree mode on your calculator. So go ahead and type that in. Make sure you can double check it. That would be 46.2 degrees. So finding an angle measurement, always need to do an inverse. Okay, you're going to have to be able to draw pictures too, so I'm going to try to draw this situation. So there's a baby monitor up on a shelf in a room. So I'll make a wall and a floor, and I have a shelf up here where that baby monitor is. And it says it's angled so you can see the image of the crib. It says the shelf is about 3 feet higher than the crib. So this distance is about 3 feet. So we have the crib somewhere over here. All right. So that's about 3 feet, the height of the crib versus the height of the shelf. And the horizontal distance from the crib is about 7 feet. So that would be about 7 feet. What they want to do is have you figure out what the angle of depression is from the light on that monitor down to the crib. So the angle of depression would be this angle up here. But the angle of depression is always equal to the angle of elevation going the other way. So you can think of it that way if that's a little bit easier. So that's the angle that they want you to figure out in this little right triangle that has a 7 and a 3. So you know opposite and you know adjacent, so that would be tangent. So tangent of theta is equal to 3/7. So to solve for the angle, it would be inverse tangent of 3/7, which works out to be 23.2 degrees. So just double check and make sure that that's something you can get. So right triangles, make sure you can draw those pictures. Okay, non-right triangles. We have a whole bunch to talk about here. I'm just going to run through the different cases for each one. So let's talk about law of sines first, and then we'll figure out our law of cosine second. So we'll kind of split this up here. All right, so law of sines. Different things can happen depending on what you are given. So if you are given 2 angles and 1 side. Those are the nice situations, because if you actually know 2 angles, you really know 3, subtract from 180, there's only ever going to be 1 solution, and you can solve for it using law of sines. So if you're given 2 angles and a side, life is good. All right, in law of sines, if you're given 2 sides and 1 angle that is opposite one of those sides. Remember, it has to be opposite for you to be able to use law of sines. You have a couple different cases to look at. So let's talk about the cases. So we have case 1 versus case 2. And this is when you're given two sides and an angle. Case 2 is when the measure of the angle that you're given, we'll just call it A, is obtuse, greater than or equal to 90. That means you either are going to have one or no solutions. If the side you're given that's across from that biggest angle is bigger, it's one solution, so one triangle. If the side across from that biggest angle is smaller, you're going to have no triangles at all. Can't do that. It has to be the longest leg. In case 1, that's where the measure of the angle that you're given is acute, less than 90. Well, there's 3 possibilities. If the side opposite is bigger, there's always one triangle. So that's one possibility. So that's a one solution situation. If the side opposite the given angle is smaller, it can be one of 3 things. It can either be no triangle, so no solution. That's if you get an error message. That means it's like physically impossible to draw that. You can get one triangle if you get 90 degrees for that first angle that you solve for. Or for anything else, it's 2 triangles. That's for any other angle that you would get. So that case 1, when the measure is of the angle that you're given, oops, I wrote this funny. Go back and fix that there. So the measure of the angle, sorry about that. So the measure of angle A is less than 90. Then you have either one triangle if it's the side opposite's longer, or if the side opposite is shorter, it can be none, 1, or 2. So that case 1 is a little bit more involved. Okay, let's take a look at your law of cosines. Law of cosines is way easier. If you are given either side, 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 so all 3 sides, or side, angle, side, there's always only one solution, and life is good. Remember to find the smallest angle first when you go through and do those solutions. So we're going to go through a couple quick here on law of sines and law of cosines. You have all the notes for those. We can go back over that as we need to here. All right, so let's take a look at the first one. You're trying to determine the number of possible solutions and support your answer. So take a look and see what you're given. You're given one angle and 2 sides, but the angle is opposite. So this is law of sines. So that's the first thing. And the angle that you're given, the measure of angle A, is less than 90 degrees. So that means you are in a case 1 situation. So this is case 1. So remember what happens with case 1. The first thing you want to do is compare the sides. That side 7 is less than 9. So it's either going to be none, so no triangles, 1 or 2. So that's what I know from that information. It's either going to be none, 1 or 2. So how do I check? Just find that first angle that we can. So it'd be 7 is to the sine of 40 degrees, as 9 is to the sine of angle B. Cross multiply, divide, take the inverse, and angle B ends up to be 55.7. What does that tell me? That tells me there's going to be 2 solutions because I got an angle that wasn't an error, it wasn't 90, 2 solutions. All right, let's try another one. Number of possible solutions for this. I'm given one angle here and 2 sides, and the angle is opposite one of the sides. So again, that's law of sines. All right, let's take a look. This is a measure of the angle that you're given. So measure of angle B is greater than 90 degrees. Okay, so that means we're in a case 2 situation. So case 2, it's just going to be one solution. So we know that we have, or none, depending on what the side lengths are. So it's either 1 or none. So we have to go back and take a look and see if it works or not. So how do we know if it's none or 1? Well, we look at the side lengths to compare. So the side we're given is 7, and we're comparing that to the 9. It's less than. Well, if B is 100, should be the longest leg in the triangle. It's not. That would be no solution. Which reminds me, I'm going to have to go back and add that onto our law of cosines. We forgot to say that. So it's one solution in law of cosines if the side opposite here, or sorry, no, we had that right. Scratch that. We were good. That was law of sines we're doing. So it was the one where we had the side length that's shorter, so it's no triangle. Sorry about that. We don't need to go back and add. I think we're good. All right, so determining the number of possible solutions, you're looking for the angle measurement and then look at the length of the side opposite. Is it longer or shorter? And that will help us figure out how many solutions there are. Okay, so some more of the determine the number here. See if we can try a couple more. So take a look at the next one. ABC, 3 different letters. That's kind of our clue in here that we don't have an angle and a side opposite. So now we're going to move over to law of cosines. All right, so it's a law of cosines because we have not an angle opposite, and it's side, angle, side. So we're just going to have our one solution. Law of cosines. These are a lot easier to deal with. All right, next one. We have an angle that's opposite again. So we have two sides in an angle, but the angle is opposite. So that's going to be a law of sines. And take a look at the angle that you're given. There's only one of them. That measure of that angle A is less than 90, which means we have a case 1 situation. Now we're going to compare the side lengths though. The side opposite the angle is 12, which is greater than that 10, which means we're in the situation where we have just one solution. So that's that nice situation. And you can think about it for law of cosines and sines. If the side opposite that you're given, the angle, is longer, it's always just that one solution situation. Okay, now we're actually going to solve. So here we have one where we're actually going to find a measurement here. They want us to find little c. Now look at what you're given. You're actually given two angles. So when you're given two angles, you really know the third one. This is a law of sines situation. So we'll go ahead and see if we can solve here. Law of sines, we'll find our other angle first, our angle C. So that's pretty easy to calculate. You guys have been doing that. So 180 minus the other two angles. So that would be 43 degrees. And we just go ahead and set up our law of sines. Little c, that doesn't look like a c at all. So little c is to the sine of 43 as, and let's see which one we know everything about. Looks like B, 42.7 is to the sine of 101. Cross multiply, divide, and your little c would be 29.7. So you're just solving for a piece. So in several of the examples on the test, you're going to be solving for the whole triangle. You could go on and find the other ones using law of sines, but that just gets us started on the first one. So solving with two angles. Those are always a little bit nicer. All right, let's take a look at the next one. We are trying to see what we have for given information. Looks like we have 3 different letters, so 3 different sides. So that's going to be law of cosines. And they're asking us just to find angle B. So normally for rounding, we always find the smallest side first. Just in interest of time here, I'm just going to find angle B. So we'll set it up. When you're solving for the whole triangle, I'd want you to find little c first, or angle C first, because it's the smallest side. But we'll go ahead and just do B here. So law of, oh, looks like I might have changed that on here. Let's just do that. Let's find C. I think that'll be better. Then we can not go in any different order than what we need to. Okay, so angle C, we'll start off with our law of cosine. So c squared equals a squared plus b squared minus 2ab times the cosine of c. So little c is 19, and then 22 squared plus 39 squared minus 2 times 22 times 39 times the cosine of c. Now remember, this is the one that people had a little bit more trouble on the solving, so we'll try to put our numbers in here. So that's 361, just double check on your calculator. 2005 for the 22 squared plus 39 squared. And then 1716 is the 2 times 22 times 39 times the cosine of c. Now be careful in order of operations. You subtract the 2005 next, which gives you a negative 1644, then divide by the negative 1716, and you get your cosine of c is equal to that ratio, and then we're going to take the inverse. So go ahead and type that in here. So I don't even simplify it, I just go ahead and type it in as is. So the cosine of c would be that. So inverse cosine would be angle c. So the inverse cosine of that ratio, which looks like to me turns out to be 32.9 degrees. So we're going to set up C that way. Then to find the next angle would be angle A, but you can use law of sines to find that. And then angle B, you can just subtract from 180. So law of cosines when you know 3 sides. All right, we'll keep cruising here. I know this is kind of a long review. We've got lots to talk about. For solving the triangle, take a look at the next one. We have 2 sides and an angle. The angle is opposite, so that means we have a law of sines. And let's take a look what the angle is. The measure of angle A is greater than 90 degrees. So that means it's a case 2. And we're going to go ahead and take a look at what they gave us for a side opposite. The side opposite is 19. That is greater than 10, which means we have one solution. So it's going to work because the side opposite needs to be longer. So we can go ahead and solve and find all those pieces. The first thing that you'd be solving for would be angle B. So we have 19 is to the sine of 120, as 10 is to the sine of angle B. So cross multiply, divide, take the inverse, and we would get for our angle B, looks like it's 27.1 degrees. Well, then we can right away find our angle C, subtract from 180, and that should be 32.9 degrees. So we have our two angles, and all we have left to find is little c. Go ahead and set up law of sines. So C is to the sine of, what was it, 32.9, as we know everything about angle A and side A, so I'll go ahead and use that. It's always better than the rounded stuff, remember. So cross multiply and divide. No inverse this time. No inverse because you're not solving for an angle, and you get 11.9. So we've solved the triangle. Remember, solve the triangle means find all the pieces you don't know. Cool. On to the next one. Solve the triangle again. So let's take a look. We have two sides, an angle opposite. And so this is law of sines again. So law of sines. And let's take a peek. The side or the angle that we're given, the measure of the angle A, is less than 90. It's acute. So that's case 1. And let's take a look at the lengths of the sides. So the little a being across from B, it's shorter, which means we have 3 different possibilities. It's either going to be none, 1, or 2 triangles. We have to figure out which one of those situations it is. The only way to do that is to go ahead and set up your law of sines and see what happens. So we're going to solve for that angle B. So cross multiply, divide, take the inverse. So it would be the inverse sine of 8 times the sine of 40 divided by 3. And when you type that in your calculator, it's going to give you an error message. Okay, so what does that tell you? Well, it means you're going to have no triangles. That's physically impossible to draw. If you try to draw it, the 3 is too short. It doesn't match up. If you would have gotten 90 degrees, we would have had 1 triangle. Anything else, we would have had 2. Okay, make sure you know how to solve the 2 solutions. There will be a 2 solution on the test. And we've done lots of examples like that using the supplement to find that third or that second set of solutions. So make sure you review that in your notes as well. Okay, area formulas. We have 2 area formulas. I'll zip through a couple of these really quick. If you're given 3 sides, I would use the semi-perimeter, so that Heron's formula. So I would find the semi-perimeter first, which is add up all the sides and divide by 2. So that would be, looks like 11.5. That's the semi-perimeter. And then the area then is the semi-perimeter times the semi-perimeter minus each of the lengths of the sides. So this is just a plug and chug. And just try that on your calculator. Make sure you're good to go. Don't forget the square root. And I got 19.8 square units. So if you have 3 sides, Heron's formula is the way to go. If you have 2 sides and the included angle, so side angle side like you do in the next one, the area formula that I would use for that one is the 1/2 2 sides multiplied together times the sine of the included angle. So that's for the side angle side situations, which works great for this one. So it would be 1/2 times 5.2 times 13.6 times the sine of 46 degrees, 30 minutes. Make sure you remember under the angle menu, that's where you grab degrees and minutes. You can type it in as is. And I got 25.7. So double check and see, and that would be in square units if you're able to get that. All right, last one, a little application question here. If you have a regular pentagon inscribed in a circle, the radius is 8. So we've done lots of questions like this. So I'm going to go ahead and put some radii in there. If I can figure out the area of one of those triangles, I can find the area of the whole pentagon. So I just have to figure out what that angle is. So how many of those triangles would there be? Well, there's 5 sides, so 360 divided by 5 looks like that angle would be 72 degrees. So what you know is side, angle, side. We know how to find the area of one of those. We just did one like that. So 1/2 the 2 sides times the sine of the included angle. figure out the area of one of those, which I believe was 30.4, if you find the area of one. Now, how many of those would there be for the whole pentagon? Well, the area of the whole pentagon would have 5 of those. So 5 times 30.4, we're looking at about 152 square centimeters. Awesome. So look over those notes. Make sure you're ready to go for this test. You guys are going to be great.